Okay, continuing on with the playlist for Laplace transforms, we got here today, we want to find the formula for the Laplace transform of sinh of AT. And before I get started, if you want to know more about the Laplace transform, you can go through this whole playlist. We start with an introduction and some other examples. So I'll provide a link in the description to the playlist, and also there'll be a link at the end of this video. Okay, so to get started with this, what I'm going to do is we're going to use the definition of the Laplace transform. So that's going to be an integral from 0 to infinity, e to the minus st of f of t, our function, but in this case, our function is sinh at. But what I'm going to do is actually write this in terms of the definition of sinh. So what that's going to be is we can write this as e to the at minus e to the minus at all over 2 dt. Now again, we could have just left it in this form as sinh and done integration by parts, and that's a fine way. I just thought this way might be a little more interesting. So continuing on from here, what I'm going to do is we have the 2 in the denominator. So what I can do is bring that out front of this integral, and we'll have a 1/2 in front. But then what I can do is actually split this into 2 integrals on this minus sign. So for the first one, we'll have e to the minus st times e to the at. And then we'll have a dt here, and we'll have a minus between them. I still need to distribute in the 1/2. And then for the second integral, we're going from 0 to infinity, e to the minus st. And then we're going to have this piece, e to the minus at dt. But the interesting thing here is this, we can actually write this one as, we can actually put this one back in the form of a Laplace transform, and the same thing with this right here. So I think I'm going to do it that way because we already have done this before. So let me just rewrite this. We have 1/2 in front. So this is going to be the same thing as Laplace of e to the at. And I did this one in a previous video here. And then here we'll have minus 1/2. And this one's going to be Laplace of e to the minus at. And the nice thing about this is we can actually use the same formula we use over here, just kind of inserting minus a as our input. So then what I'll do is I'm going to factor 1/2 up as we have 1/2 in front of both these. Now for this Laplace of EAT, the formula we found in that other video, and I'll provide a link to that one in the description, is 1 over s minus a. We had a condition on this that we need s to be greater than a, so let's just keep that in mind. And then for the second one, we're going to have the same formula. We'll use 1 over s minus a, but in this case, we're inserting minus a in there, so we'll just kind of write it like this, and we'll have minus a as the input. But then minus times minus is plus. And so in order to simplify this, I just need to get a common denominator. So like here, we'll multiply by s plus a over s plus a, just multiplying by 1. And then doing the same thing, same kind of thing over here, we'll multiply by s minus a over s minus a. Sorry for the mess. So then we'll just simplify this. We'll have our 1/2 in front. Now we're going to have this the common denominator in both these. When you multiply s minus a times s plus a, we can write this all over s squared minus a squared. And then in the numerator here, we're going to have s plus a. And then here we're going to have s minus a. But we have a minus in front, so let's just keep that in mind. But then distributing in this minus, the s's are going to cancel. So then let's rewrite. We'll have 1/2. Now we're going to have a minus times minus is plus, so we're going to have this is going to be a plus a in the numerator, or just 2a, and this is going to be all over s squared minus a squared. But then the 2's are going to cancel, and so for our final solution, we're just going to have a over s squared minus a squared, and we just need to remember this condition that s has got to be greater than a. So that's it, Laplace of sinh at. We'll stop it there. Thanks everyone for watching. Have a good day.